Hello, and welcome back. And welcome if you're new. In our previous video, we have coded our text normalization function. We are coding our chatbot using natural language preprocessing, which is a process in machine learning. And we are coding our chatbot here. And in previous video, we talked about what is text normalization, and we coded our text normalization function. We have done some code previous to that in previous video, where we took our we talked about all of these libraries. We have imported our data set and made data frames. We filled NaN values. Then we looked into our data. We talked a little bit about text normalization to word tokenization. We talked about POS tags, and we talked about lemmatization. So in this video, we will continue coding our chatbot. And if you want to learn about chatbot, I will highly recommend you to check previous videos before this video, because we talked about all of this in very depth in that video. So in previous video, we actually have created our text normalization function. We talked about text normalization function in that video, and we tested our text normalization function here. In this video, we will go ahead and make a data frame, or we will say def, and be very careful with your spelling, because that can cause some issue if uh, if done wrong, because we faced some issue because of our what we call spelling mistakes. And yeah, I was just checking that we are recording or not. So after this, we will go ahead and say okay, let me put this here, text which is equals to, if you're thinking what I'm looking into my notes, so that I can tell you like important information and I don't miss out on anything. What I'm saying that make a column which will take a text context column from df, and apply text normalization with the function which we made, text normalization on that. So what we are saying that take a context column, which is this column. Take a context column, apply this text normalization function on that context column, and make a column lemmatized text, a new column. And when we do that, and we check what is our data present after doing text normalization on context column, and after our program makes lemmatized text, what we get there, we will wait. So here it is, and as you can see that this is our context column, this is our text response column, and we apply text normalization on our context. So here we can see, tell me about your personality. In our text normalization function, as you can see, we are converting strings, every text into lower. So every text is converted into lower case. Tell me about your personality, I want to know you better, I want to know you better, define yourself. So this proves that our text got normalized because of this code which we wrote. Now we will create a bag of words. Or occurrence of word in dataset. We will check the occurrence of a particular word in a dataset. So we will go and say cv, and it will take count vectorizer or vectorizer. It will take a count vectorizer function. What is count vectorization function? Here, as you can see, we have imported our count vectorizer function in from feature extraction.text. So if you watch our first video on chatbot, where we talked about each and every library, I have explained the text count vectorization function there, and I have explained about sklearn feature extraction.txt library there. So we will take a count vectorization. Essentially, count vectorization actually takes, like, in very basic words, it will count the number of time a particular word occurs in a data set. In very basic words and very plain simple English. So we will say, okay, we are saying CV is equals to count vectorizer function, which we import, which we got from sklearn.featureExtraction.txt library. So it is a function under the library sklearn.featureExtraction.txt. So we will say x cv underscore fit in transform. We will fit that data and transform. Let's say fit cv transform. This will fit our data in our cv, which is count vectorizer, and here we will pass this df because that is our lemmatized text. So let's say lemmatized text. Okay, lemmatized text, and we will say dot. Okay, we will say dot to array because we want to store the count in an array. So what we are doing here, we are saying that get a count vectorizer function, and we will fit our data with, which is our this data frame lemmatized text, which we got from here, to count vectorization, and we will transform and go through the data where to find out the number of occurrence of a particular word in our data, and we will store that number to an array. So over here, when I say this, and if we check, go and check, and if I say df, let's say x, let's just do this. So as you can see, here is a list of arrays, and as you can see 0 1 0 1 0 0 0. So where 0 is there, it's significant that that word doesn't occur in this array, in this array, and when there is 1, it signifies that a particular word occur there. Now we will say that give me all unique values or features. So what we can do is we can say features, FATURAS features, and you can name this anything. You can name your name here because we are making a variable essentially, and if you know, you can name variable anything. Exceptions are special characters, so be crazy with your variable name. But the good practice to name a variable is to actually give a good variable name so that you can actually explain to next person what that variable does. So we will say CV, which is our count vectorizer here, and we will say get features, feature names, MES, and this. So what is this? So we are saying from count vectorizer get a function get underscore feature underscore names. So there is a function in count vectorizer which goes by the name of get underscore features underscore name, and we will say that df dot bow, you can name whatever you want. BOW stands for bag of words. We are creating essentially a bag full of words here. So we will say PD, which is our pandas, and we will say data frame to get our data frame. Like we want to work with our data frame, so we are saying data frame. We will put X here, and we will say columns is equals to features. So what this line does? Essentially, this line takes data and store into X, which is a fit and transform data. So it is taking data which is fit and transform and storing that into X. And if you want to look at df.bow, go ahead and say df underscore bow dot head, and we should get a table, a row and column. Okay, there is an error. Data frame, what's wrong? Okay, it should be capital F, data frame. So here it is. So as you can see, it has created a table of 5 rows and 490 columns. So 0 to 5 is our row, and this is 490 columns, and essentially it is showing our bag of words here. So this is how we create a bag of words. In next video we will talk about how we do stop word removal. What is stop word removal? So to give a quick bite of it, a stop word removal is basically removing unnecessary words which we generally don't want in which machine doesn't want in computational process, just for example articles and everything. So when we remove it, which actually give us effective code and effective runtime. So we will do stop word removal in our next video. So till then, be happy, spread peace, and take care of yourself. Subscribe, like, and comment, and yeah, if you want to help me, you can help me in that way. So see you in the next video.